Thank you everyone for coming to today's webinar, to the next edition of the Pages ECN Webinar. Today's webinar is titled From Idea to Paper in the Paleogeosciences, using RMarkdown to make your work easier and better looking. Today's webinar will be hosted by Dr. Simon Goring. Simon is currently an assistant research scientist with the Department of Geography at the University of Wisconsin-Madison in Wisconsin, United States. Simon received his PhD in biological sciences in 2012 from Simon Fraser University, British Columbia, Canada. Simon's research focuses on understanding relationships between biotic systems and large-scale climatic change on centennial to millennial timescales. And he's here today to introduce us to RMarkdown and discuss about reproducible workflows using data from the Neotoma database. So with that, I will turn the attention over to Simon.
All right. Thank you very much, Michelle. We've had some issues with Wi-Fi connectivity. Hopefully they're all sorted out. If there's anything like connection issues through the talk, just let me know through the chat, I guess, and I can wait until we get connection again. There is also a bit.ly link here on my main slide. Let me just get the pointer here. There's a bit.ly link on my main slide right here. It's got some links to some of the content, to the talk itself on GitHub, on Google Slides, and has some links to other resources that you might be interested in. So what I really want to talk about is this idea that ultimately as scientists, as academics, we often think of our main research product as a paper. So we publish papers, we are working towards writing our theses or reports for people, and ultimately when we think about the final product, a paper, it tends to be a very linear thing. We start out with an abstract and an introduction, have some figures, we talk about the results and the discussion, have a conclusion, and this is a very linear thing from top to bottom. But when, speaking for myself anyways, in grad school and even now working on projects, the process to get to this end result is not linear at all. We do a lot of stuff where we bring in data, we sort of mess around with ideas for how to actually test our hypotheses. We accept and reject certain ideas. Thank you, Windows, for that pop-up. And eventually we wind up at something that looks like a paper, but the way we got there was not necessarily linear. The other element that really sort of we need to consider is that a paper lasts forever. As soon as it's in a PDF, those statements that we make in that document are unchangeable. And if they are generated by code, if they're generated by code that's using external data resources, it might be that those results may change. And so maybe they're not numerically significant, the changes, maybe they're just small changes, but potentially they could be very big. So for example, if Neotoma were to if your data relied on Neotoma and Neotoma was missing a bunch of pollen samples from a region, you made some sort of statements about that region and its characterization through paleoecological time, and suddenly someone dumped a whole bunch of new sites there, you could see that perhaps some of your findings might change. So when we think about a paper itself, you're getting data coming from multiple sources. So some source might be this red one, this sort of peachy color, this green color. We tie it all together through some sort of analysis. So whether you're using Excel or R or Python to transform the raw data into some sort of finding, a figure or something like that. And then in our results and in our discussions, we make some sort of assertion about how those data transformations result in some sort of knowledge. A P is less than 0.05, or talking about credible intervals if we're doing Bayesian analysis, or even qualitative assessments. So we go from making some sort of general statements, bringing in some sort of data, transforming that data, and then making some sort of assertion about that data based on statistical analysis. So fundamentally within a paper, all of these sets of elements are interdependent. They all rely to some degree on the primary data, and the assertions that we make in our results, in our discussion, are dependent on both the data and the analytic steps. But they're not all necessarily interdependent. So the things you might say about this peachy color maybe don't affect the things you say about this reddish color. All the same, they're all tied up together. So what I want to sort of convey in this talk is the process that I have gone through from being a graduate student working on a bunch of different R files and a bunch of different data resources to where I am now, and how my workflow in terms of building a paper and building sort of an analytic unit has really evolved from sort of just trying to do what works to really sitting down at the beginning of a project and thinking about workflows that help me load my data efficiently, link my text and analysis, and then ultimately produce reports that just work. So I can send you all my code, you can just run it straight off on your computer and basically get the exact same report that I do. The other thing, so that saves time, obviously, because we don't have to have a whole bunch of back and forth where you say, Simon, I don't know what's wrong with this thing. And I'm going to show you some tricks that do some impressive stuff in those reports that look cool and impress advisors. So that's always helpful. In general, my workflow is sort of like this. So I use GitHub for collaboration and to back up my data and my code. In practice, everything that I do is open. I have very few private repositories on GitHub. If you ever wanted to see what I am working on, you could go to GitHub and see everything I do. In part, that's because I think I do really obscure stuff, so no one's out there to scoop me. But also, I think that's because that's sort of the ideal world I would like to see. I am in a position now where I can do that without having to worry about being scooped. I think for other people, those are choices they need to make, and I'm not going to advocate a completely open workflow because people are in different circumstances than me. I'll just say I think it's a good thing that people should work towards, but they need to consider their own circumstances. A lot of my stuff depends on Neotoma, the Neotoma Paleoecology database. For those of you who aren't familiar, it is a database of fossil pollen records. We have, I think, 28 different data set types, including diatoms, ostracodes, water chemistry. There's XRF data in there, loss on ignition, charcoal, all sorts of things. And it's a very integral part of a lot of my workflows. So I write and I code using Neotoma data that comes in from R. I build my documents using RMarkdown. I commit my code to GitHub and push it up. And then I use continuous integration systems like Travis to actually build my documents, sort of reproduce this step here, build my documents in the cloud to make sure that the success that I have on my computer in terms of building nice looking documents can be replicated on an independent system. And I have a sort of a blog post on my website, you can link to it right here, that shows you how to actually do that. So let's start at the beginning. If you, and this is the way I sort of work, if I come up with an idea, if I say, hey, I'm really interested in how this thing might work, what I most often do is start a brand new project in RStudio. RStudio is a development environment for people who use R. I really like it. I use it and another program called Atom. in developing things for R. There's a bunch of packages that I use in addition to that. I'll talk about some of them. One of them is use this, and use this sort of helps you set up your projects. This here is a convention that I use quite often in R. So this tells R that I want to use a function like use readme.md, and it is coming from this package. This is really useful because some packages, especially when you start using lots of packages, some packages use the same function name, but they do different things. And so explicitly calling the package name is sometimes really helpful. I also use a package called linter, and that sort of gives you, it tells you if your code matches some sort of style guide. It's really nice. It just makes your code look nice. So I use this often to initialize my projects, to sort of add some support documents, and then I use RMarkdown to write down my ideas. I just want to, okay, yeah. So RMarkdown is really cool. Here's a teeny tiny screenshot of what something in RMarkdown might look like. For those of you who aren't familiar with RMarkdown, what it does is it combines your R script in line with your document. So you can write plain text stuff, whatever you want. You can use heading levels, you can bold things, italicize things, you can add bibliography to your document as well, and you can integrate it with the actual code. So when RMarkdown actually renders your document, it runs the R code and sticks in the outputs into the document itself. So you wind up getting an HTML file or a PDF or a Word document that integrates all of your analysis and your text. And that's really been a big change for me, because what it means is that that document becomes software effectively, and software developers have so many amazing tools for helping to manage their projects that it suddenly allows you to manage your R code, your whatever software code you want, and your documentation as one unit, and then take advantage of all these things like GitHub. So it becomes a very powerful tool. So let's sort of come up with a project, and we'll walk through this a little bit. For those of you who are familiar or who aren't familiar with Neotoma, let's see if we can do this. Neotoma, there's about, I think at last count, there's like 16 million unique observations of data sets in Neotoma. There's data that's come from the European pollen database, the North American pollen database. We have geochronological information. There's data coming in now from the African pollen database. Lest you think it's all pollen, there's also data from FaunMap. I don't know where these things go. Oh yeah, and then we have a graphical interface here, the Neotoma Explorer, where you can actually look at the individual data sets and get some secondary information about them. So here you can see I'm pulling up some information about site from FaunMap. This is some sort of record about, I don't know, some sort of bone. Oh, this is a bone collagen record. And so oftentimes the information is useful, but this site, for instance, has no site description, and that is something that we can provide from Neotoma, but on occasion do not. So in this project, what I'd like to do is I'd like to use Neotoma's API to look for sites that do not have any site description information, so I can start going back and seeing why are there other factors that lead to these sites not having information? Maybe one particular data set type just doesn't have the site descriptions. And this is more an administrative thing. It's just an easy example. It's more of an administrative thing, but it means I can pass the information on to the data stewards. So I'm just going to open up our studio here. I've already got it open. And because this is sort of a new thing that I'm working on, I'm just going to start out with a new project. So I clicked File, New Project. I'm going to go into a new directory. I'm going to start a new project. And I'm going to call this Site Descriptions. So that's great. I'm just going to put it in my main folder. In practice, on my other computer, I have a folder called GitHub, and that's actually where pretty much all my projects go, because then I link them up to GitHub. So we're going to see now our studio starts a brand new session, cleans everything up, and it looks basically the same. You can see now here on this sort of this bottom right-hand panel. I don't know, can you see my mouse as I move? So in the bottom right-hand panel, there is the file locations. This is the R terminal, and then this global environments area up here would be where variables that I create pop up. So the first thing I want to do is sort of keep track of my ideas. So I'm going to start a new file, and I'm going to make a new RMarkdown document. I'm going to call this Site Description Analysis. It's a great name. I'm going to use the output to HTML because I'm going to show you some stuff that takes advantage of HTML. You can also make presentations, Shiny apps, other things, but for right now, I'm going to generate this RMarkdown document. If I were to run this right now, you can see this that I've highlighted. We call this the YAML header. YAML is a kind of markup language. You have a variable and a value for those variables. And it basically just sort of tells RMarkdown how to actually render this document. I can hit knit right now, and what you will see is, oh, first I have to save it. I'm going to save this as, So I'm going to save this as descriptions.rmd. It's going to render it, so it's going to turn this into an HTML document, and so you can see some stuff happening down at the bottom. And in this code, I'm going to just switch here first. So in this code, it's going to load information from the stats package, and it's going to make a plot. This is again data that comes from the stats package, and it's going to put that together with the text that's in the document. So if I were to switch documents, what we would see is there's the title I gave it, my author name, the date, here's the first heading, and then here's the stuff that was already there in the template. And if I scroll down, there is the plot that was generated. This has nothing to do with what I want to talk to you about, so I'm just going to clear all this out, and I'm going to write site descriptions. And I'm going to say I am interested in what sites do and don't have site descriptions in Ontario, Canada. So I could do this for a broader set of sites, but I'm not going to, in part because I'm not entirely sure how good my Wi-Fi connection is. So there's my text. Don't have site descriptions from the Neotoma Paleoecology database. Okay, there we go. So there's my text. If I want to put in a chunk of our code, I use this sort of text. So it's 3 backticks, squiggly brackets, the letter R, And then you can see all of a sudden our Markdown or our studio recognizes that this is code. It's done this little graying. And so I'm going to load the Neotoma library. I'm hitting Control Enter to send code to the terminal, to the console. And then once the Neotoma library is loaded, I'm going to create a variable called dsOntario, and I am going to send the get dataset command from the Neotoma library. So get dataset is a function in the Neotoma library, and it allows us to do things like ask for, we could ask for all datasets, we could ask for all datasets that are pollen surface samples or vertebrate fauna or something like that. We could ask for all sets between a minimum and a maximum altitude. We could use a bounding box. And we can combine any of these things as well. So I'm just going to create it using the GPID, and I can say so GPID is for the geographic place, and I'm going to just say Ontario. You could ask for all data sets from Switzerland. You could ask for all data sets from the United States, things like that. So I'm going to run that. And you will see, so it sends back a little message. I've got 3,890 records. That's great, wonderful. And then it takes a little while, partly because this machine is slow, but it's going to take a little while and return some data. Oh, there it did. Okay. So if we think about our paper as software, then that means we can use this version control. We can use other things like code coverage, AppVeyor, whatever. That's great. There is good documentation about how to link your local directory to GitHub, and then some other information about using Git and using Git init to actually initialize a directory. I'm not going to go into that too much here, in part because this was I had to install Windows, and so I don't have Git installed. But I will say that taking the time to learn Git made me a much better coder. Much better at editing my things, much better at avoiding kind of weird mistakes through the process of doing my work. And although it can be complicated at times, it was by far one of the most valuable investments in my future career that I made. So go back to that slide and take a look at those things. And I think in my website I have some stuff that talks about it as well. So the other thing is just, we've already started pulling in data. Once you start working, you don't want to wind up with a directory that looks like this with all sorts of, there's some CSV files. I don't know what these CSV files are for. They've got different names. There's similar names. There's one that's just called edit frame, list names, publications JSON, mark DOIs. Like, I've got files all over the place. Plus I have data folders and image folders and output folders and stuff. Who knows what all that is? Take the time at the beginning to set up some folders, and in general, in all of my workflows, I find that the most useful set of folders to make are a data input and data output folder, an R folder, a figure in that R folder just for the code that makes your figures, then a figures folder, which would be the output figures for your paper, and then finally the cleaned up ones that you're actually going to wind up printing. So let's switch back over to RStudio. In RStudio, you can just go and create new folders. So I could create a data folder, and I can create an R folder, and I can create a figures folder, And then in my data folder, I'm going to create an input and an output folder. So that's great. We have this call. That's fantastic. Oops. So I'm going to just make a little statement here. We downloaded the data and it was cool. We got, so now I want to say, how many sites did we actually get? How many data sets did we actually get? And one of the nice things about RMarkdown is it lets you do bigger analysis in these code chunks, but it also lets you put results from there directly into the text. So I could say a single backtick in R, that tells RMarkdown that I'm just about to report like a single value right in the text. And so I can say we got length DS Ontario data sets when we and so if I actually ran this, I would get a value of 3,890. And when I knit this document, what it's going to do is it's going to run through all the code again, and it's going to get the data sets, and it's going to paste that number into the text right here. So I'm going to get a new HTML document that's just going to overwrite the old one, the descriptions.html. But you can see right now that it's taking a bit of time to run, and that's because every time I run this right now, it is going to go out to Neotoma and download the data set and then try to recalculate this value. So I just want to see if that's where I am. So we've sort of started this new thing. Right, okay. So that takes a really long time. All I'm doing right now is I'm downloading just the Ontario data. But I do other analysis. So let's see, is it still doing this? Okay, so it's generated it. That's great. There's the call. I do some analysis where I download the entire set of Neotoma records, and that can take hours potentially, depending on my Wi-Fi. So over the course of working with R and with Neotoma and with large, complicated analysis, I've discovered a little trick. And that trick is that you can save R objects. So some of you may know you can save R data files. I like to use a file format called RDS that's also native to R. And so what I would do after this call is I would say, here's my DS Ontario, and so I would save RDS DS Ontario. This is an output file as far as I'm concerned, and so I'm going to send it to data/output DS Ontario.rds. And so this is taking that file, this is taking this data set object, and it's putting it into the folder output Ontario RDS. So I can click over here and see that. That's great. So it's a big file, 200 kilobytes. Now, the really cool trick is I can use R's ability to look in files and folders, and I can say, so I'm just going to go down here to the console at the bottom, and I'm going to say list files data/output. And so there I'm listing the files in the directory, and I see DS Ontario. So I can put an if statement up here that says if DS Ontario is in the list of files in data/output, then instead of downloading the get data sets, I'm going to say DS Ontario becomes read RDS data/output/DS Ontario.rds. If it's not there, then download it properly and save the file. So most of the time that I run this now, so let's knit this, most of the time I run this now, it should go fairly quickly because all it's got to do is load that file into memory and then output the value, whatever that length value is. So it's a really nice trick. It saves a lot of time, especially like if you're doing things like multi-dimensional scaling or something like that that sometimes take a really long time. Oh, whoops. Haha. There, let's do that. Okay, that time, now it's going to run faster. I forgot to include the file extension. There we go. So that was a lot faster. You can go even further with this. So in this case, this is sort of assuming that data in Neotoma doesn't change very often. My big analysis steps don't change very often. And the way that I would get it to re-download the data from Ontario is I would just delete the files in that output folder. Another thing I can do is I can actually add a version number and say version is equal to 1. And instead of using this, DS Ontario, I would use the paste statement to stick together the version number and the file name. So I could say paste 0 DS Ontario version.rds. And in this case, I don't have to delete my old files. I will be able to keep a version 1, a version 2, a version 3, and see how my analysis has changed through versions just by changing this version number. For all intents and purposes, I'm going to just get rid of that right now because I don't want to deal with that. We're just going to pretend we do this once and it's cool. So that's great. That's sort of a way to deal with big, long, time-consuming steps when you're knitting this document. The other thing I wanted to show you is how RMarkdown makes data exploration and stuff a lot easier and gives you the power to do really cool things. So let's just take a look at where the sites are. So the Neotoma R package has a link to an application called Leaflet. Leaflet is a web mapping platform, and it can embed a web map directly in your HTML document. And so again, we looked at where the sites were. So there's lots of ways of plotting XY data. The base mapping in R is kind of ugly. Some of the mapping stuff is complicated. What I wanted to do when we wrote the R package was make things really easy for people and make it easy to explore the data a little bit. So I wrote a function called plot leaflet that works with the dataset objects. And what we can do is, let's knit this again and just take a look at what happens. It should be relatively quick to load the dataset because we added in this read RDS thing. Now it's going to add into the HTML a chunk that actually produces an interactive web map because we're going to HTML. So if you exported this to a PDF or exported this to a Word document, you wouldn't be able to interact with it. But because we exported this to an HTML, I can go in and look at these sites that I have generated, and maybe I'm interested in this site. So site 1, mod unpublished, and this will open up a new link to the Neotoma Explorer, which you saw earlier. The other thing it lets me do, which is really nice, is Neotoma is a user-contributed database, and sometimes there are data sets that have been misentered or something like that. So here's a site. I downloaded everything that said it was in Ontario. This one says it's west of Milton, which should be like down over here, but for some reason it's over on the New Hampshire-Maine border. And so I can go in here as well and take a look at it, and I can report this issue to a Neotoma steward. So this is a really nice way to allow people, your collaborators, to sort of interact with the data as you're doing your analysis, and also works as a sanity check for you as well. Like, why are these sites up here? I don't know. It seems to be in the right place. It says it's Arctic tundra, just for some reason it's entered as being from Ontario. And we can go even further. So this is really cool, and I can do this. I have this in some of my documents. It lets me play around with the data a little bit and link to it when I'm doing some exploratory data analysis. I can take this DS Ontario, so let's just do some analysis. How many sites are bad? So how many sites don't actually have data set descriptions? So in our paper, in our open quaternary paper, you can find it by looking at my Google Scholar page, or R has a really nice function called citation, which will give you the citations for packages. So if you use the Neotoma package, you can just go here. It describes the kinds of things that are in these data set objects. I happen to know off the top of my head what I'm looking for, so I just want to say I want the number of sites without, the number of data sets without descriptions is, what is it? Well, I need to get that value, I need to do a little bit of analysis here. So I'm going to just write this. And so I'm going to say, so the dataset descriptions comes from an sapply function. So a dataset object, like the dataset object we downloaded, is actually a list in R, and I can apply a function across the whole thing. So for each of the elements, Ontario, for each of the elements in DS Ontario, I'm going to apply a function that goes into it and takes the site data element and then just looks at the description. Oh. That's all it's going to return. If I do that here, what we will see is that now I have, you can see over here in this values panel in the global environment, I now have a variable called ds_descript, and if I look at the first few elements in it, you can see that the first one, the first site, whatever it is, says it's a bog. The second one doesn't have any information for it. The third one has some pretty good information. It tells me about the origin of the lake, the physiography, yada, yada, yada. So if I want to actually find how many don't have any information, I can just go in here and say the number of data sets without descriptions is R, the sum of isNA ds descript. And so that's going to tell me some information. So out of this, like 3,000, only 443 don't have a description. Well, that's great. What I originally said is I want to know the data set types and the description information. So I can go a bit further. I can use ds_descript, and maybe I'm just going to say, I don't actually care about what the description is. I can also get the dataset type, and so I can say ds dataset type is the same sapply, so I'm again going to apply a function across each element in this list. And this function is going to take x $dataset meta, and I think it's dataset type. Let's see if that works. I'm pretty sure it will. Oh, sorry. I forgot a period in there. Dataset type. All right. And so if I look at the table of DS dataset type, I can see that of those 3,000 some odd records, I pulled in 1,499 water chemistry records, some testate amoeba surface sample records, 144 pollen cores, 1 paleomagnetic record, 164 diatom records, some ostracode surface samples, some vertebrate records, all sorts of stuff. So what I'm interested in is how many of each of these record types have no description. So why don't I make a data frame with the description is equal to ds descript, and type is equal to ds dataset type. So so now what I can do is I can do a table. Oops. Wait, I don't want to do that. I just broke our. Sorry, guys. All right. So I could actually add in a dynamic table in here. And I can't remember how I did that last time. What did I do? Oh, right. Oh, you know what I did? Just a second. Table ds dataset type is NA. All right. Anyway. Okay, this is what I want to do. I just forgot it. Here, run there. Okay. Okay, there we go. So, so I can look here and just see that, and I can get this table. That's great. Whatever. I can also make this a bit more dynamic now using a package called DT. So DT is a plugin to the JavaScript data tables package. And so I should be able to, if I'm right, ds df dot type ds df $ description. Can that work? Okay. So there, what you see on the left hand, or on the right hand side, is like a very small thing of the table. What I'm going to show you now is what this whole thing looks like rendered. So let's knit this again. And the nice thing about this and about having these dynamic elements is, again, this lets me explore the data set a little bit better. I'm using data tables with really the most basic settings. There's lots you can do to add like shading and different kinds of search bars and stuff like that. I just zoomed out of that map too far, but here's what the data table looks like. So I can drop these variables if I wanted to, but what I'm going to do is I'm going to sort by the data set type. And so when I do that, why isn't it doing that? So I could look at the frequencies. So terrible. So here I can see, what are the frequencies of the diatom sites that don't have descriptions, or how many pollen sites don't have descriptions, how many chemistry. So I'm using the search bar that's built in. So I'm using this sort of dynamic web technology in this report that I'm doing so that I can help and start to explore these data sets. It's super awesome. And I can't emphasize that enough. So there's the versioning that I talked about. Here we're adding data tables and leaflet. So here's the other thing that we can do. So we've shared the document. We can do this and make it so it's shared using GitHub, those kinds of things. We can link the repositories. One of the other things that we often do is we make qualitative statements in our documents. And those are really challenging to fix when we start editing things, because sometimes we forget that we've made them. We don't know where we've made them. And if the data changes, they're hard to pick up sometimes. And so one thing we can do is, this is effectively an assertion. And so if we are making this assertion, then we should be able to use a package called assert that in R to express that assertion in terms of the data. And the cool thing about assert that is, if this assertion works, then it just passes on a true and it sort of ignores it. It works silently. If the assertion is false, it returns an error and it will actually stop your document from being built. And you can give it a custom message as well so that you know exactly what happened. So let's go back here. So there's cool stuff. Let's say there are more, I can't remember. There are more there are more insect samples with descriptions than without. So let's pretend that at one point that was true. If I look at my data set now, I can see that for the insect records, more data sets do not have descriptive data than do. But let's pretend that when I did that originally, it didn't. And now I'm going to put this assert that. I'm going to assert that ds df $, description. So ds df description is true or false because I did that up here. I made it an is NA. So I should be able to say that the sum of ds df description where ds df type is equal to insect is greater than the sum of the inverse, not that. Hopefully that makes sense. So I'm basically saying the sum of the values that are true, where it actually is an NA, should be greater than the sum where it isn't. And I can just test that out down here, and I should get a false. Because there are more samples oh, sorry, there are more samples that do have descriptions than don't. Anyway, so that's my assertion. I already know that it's not right, and I'm going to add a little message that says there are more described insect sites than not. Close that fencing, and here's some more text. So I've made a qualitative statement here. I've made an assertion that should support it, and I know that if this assertion breaks, this sentence is wrong, and I know exactly where to fix it because it's in line with the text. So when I knit this again now, I'm still going to get my, well, I'm not going to get anything. I should be getting my leaflet map. I should be getting my data table, but what you'll see down here at the bottom is that all of a sudden there is an error. It tells me on line 57, there are more described insect sites than not, and the execution was halted. It just stops. And so now I can go back here. I know I'm at line 57. I know exactly where the assertion was and where the error is. And so I can change this and say there are, oh yeah, well, it's right. Shoot. But I can change the assertion here, and now I say, okay, well, I've changed this, so there are actually more insect samples with descriptions than without. And now the assertion will pass until new data comes in and there are less described insect sites than not. So I just switched around where that exclamation mark was. Doesn't matter what your assertion is, you just have to figure out how to do that. And now when I run this, what's going to happen is it will actually run. And so I know that my qualitative statements now are right in this standard version. And until new data comes in, everything's going to run. It's going to be fine. I'm not going to have any problems. There's my little true statement. So there's lots of tools we can now use if we think about our paper as software. We can use these sort of breakpoints and these checkpoints. There's lots of other stuff you can do. You can use different templates. There are different CSS things that you can do. There's some really great documentation online about managing your YAML header. I have some GitHub repositories. So our repository for this project, this bulk baconizing project, this is a project that we have just finished that will regenerate bacon age models for like hundreds and hundreds of sites and in a sort of semi-automated way. You're welcome to use this, to clone this. There's documentation here. The URL is right up there. It's in the Neotoma GitHub repositories. And you can see in the top of this, of the RMD file for this, once it loads, you can see that it's got this YAML header that I showed you earlier, but it does a bunch of extra stuff. So actually, instead of just a name, there is an author term, and I can put in the affiliations. I can use different kinds of code highlighting. I can add a table of contents to the document. I can do code folding, which means that the code is generally shown, but you can hide it if you don't care about it. It lets you do all sorts of cool stuff. You can add bibliographies as well, which is really nice. But ultimately, when you get down to it, what all of this lets you do is it takes this idea that in these papers, your text is so dependent on the analysis that you do that your code and text should be intimately bound. And for that not to get totally overwhelming and unmanageable, you need to keep your code and your text well managed. And that means not just writing good code, which is difficult, I think, but not unmanageable. But you also need to really think about the folder structure, using version numbering, and keeping your data as clean as possible. And part of that is saying, if I'm going to do any analysis on it, I'm not going to overwrite the original file. The original file is always going to be on its own. And I am going to do that analysis in R in really clean and clear steps. The other thing this lets you do is use a set of tools to help you manage your code and help you manage your documentation. Some of these have a learning curve. I'm certainly open to talking them through with you, but I will say that over the course of my coding, one of the things that has made me much more effective and much more efficient is taking the time to learn how to use things like assert that, use things like git, and use things like linter, which helps you add a style guide effectively to your R code. And that is basically where we're at. That's the end of the talk. I'm sorry I ran a little over time. And so if you have questions now, you can ask. I think that we can use the Q&A.
Yeah, you should be able to just type in your question here in the upper right-hand Q&A box. If that doesn't work, then you can always type it in the chat box. I've got a question. While you're thinking of a question, how to maybe formulate your question, we are recording the webinar and we'll post it on our YouTube channel within the next couple days. So if you need to watch the tutorial again, please head over to the YouTube channel to do so. We've got a few people typing questions. Great.
Great. And so I will say that this link, this bit.ly link right on the front of my slides, goes to a document with some other helpful links. So we now have, I don't know how many of you are familiar with Slack, but Slack is sort of like an online chat program. And so Neotoma has its own Slack channel now. You can ask questions about coding in R, data, building age models with Neotoma records, those kinds of things. It's a public forum, and you're welcome to join there. You can also link back to my presentation directly if you want. I talk about some of the R packages that I use and install. And then here's some of the code that I used, or similar to the code that I used. So.
All right, so Pablo says there's no questions. Thanks for the presentation. Hobby says if you would prefer to ask for mic permission, you're more than welcome to, and I can unmute your microphone if you'd prefer to ask a question live. Otherwise, if there are no questions, Simon?
So one other thing I will say is that I do a lot of the coding for Neotoma things. And I definitely recognize, I mean, I've been through the struggle of trying to understand how things work and reading and working through resources that were poorly documented. It's always a challenge to do the development and do the documentation. One of the other reasons that I do a lot of my stuff publicly and allow people to access it and share it is that I also very much welcome collaboration. And so I don't think anyone should ever feel ashamed that they can't code to the same level as anyone else. There's so many opportunities to contribute, and one thing that I really value is people being able to contribute, you know, and just say, this thing isn't clear to me, or I worked through this and, you know, here's a way that I would potentially change what you've written. If you do use Neotoma, I would love to know about it. and I would love to know about the issues that you faced. I don't take it as criticism at all, and I think it's a really valuable way that people can contribute back to the community. So,
wise words. I appreciate that because I definitely am not the smartest person when it comes to R in RStudio, and I've never used RMarkdown, so I appreciate the suggestion and advice, Simon. Jeffrey says, this is great, really appreciate the intro, planning some work with Neotoma, and these are very helpful. If the participants have any questions that you think of, Simon, do you mind writing your email address or showing the link, showing your email address somewhere so people can contact you?
Yeah, so you can go to my webpage is goring.org, and my email address is there. Just a second, let me just type this here. Goring. I have to switch to my phone to do this. So there's my email address, and my website is there you go. And there's my website, and there is a resources page that actually has also some more Neotoma stuff in here. So.
Do you have any other R Markdown stuff on your website?
All of my stuff is R Markdown stuff in general.
Okay.
And so if you go to my GitHub repository, which you can get to either through the Neotoma repository or through Simon Goring. I can put that in as well, or someone can type that maybe for me. What you will see is, just a second. Let me see if I've got some good ones here. I don't, as I'm scrolling down. You would, there's a lot of R Markdown stuff in here. I don't know if this is. So Jeffrey asked about Atom and what advantages there are. I actually thought about that a bit and wrote something about it somewhere. Here. So Atom is a bit more lightweight than RStudio. I have found I mostly use Linux now, and I have found that sometimes RStudio can be really slow for me. Atom and lately, because we're doing a bunch of stuff on the back end of Neotoma, I have started coding in other languages as well. So I use JavaScript and I use SQL as well. And so that means that, sorry, I think my network just dropped. And so that means that Atom is really useful because it's, okay, well, you can't see it, I'm sorry. Atom is really useful because it's built for multiple different kinds of programming languages. The other advantage is that it is really, I've sort of changed the way that I actually write R Markdown documents now. So I often will use a little script that looks at the directory I'm working in, and anytime I save the document, it just renders it in the back end and rebuilds the HTML file. And so that means I don't actually have to use RStudio and like the R console. I just have to edit in plain text and then see sort of what the results are. I think that's more advanced than we need to talk about here, but it's well suited to using Atom rather than RStudio.
Great. Any other questions?
All right.
Okay. Well, thanks a lot, Simon, for hosting today's webinar, and thank you for all the participants for joining us today. Feel free to contact Simon if you have any other questions, and feel free to contact Pages ECN if you have feedback, comments, suggestions for future webinars. We're happy to serve the early career network community, and thanks for joining. Have a good day.
Great. Thank you very much. So the first question is from Chris. So Chris, as I have not linked the interactive table and HTML maps, however, in the leaflet package 4R, it allows you to add a bunch of extra plugins. So fundamentally, it uses a package 4R called HTML tools, or HTML widgets, I think, which lets you interact with JavaScript. With JavaScript applications. Leaflet itself lets you interact between JavaScript rendered tables and the leaflet maps. So it's not a direct thing, but yes, you can. So I just don't have the answer. So then Barry has asked any tips on transitioning. The first thing I would do if I was transitioning, so I have done this before, I often just start by taking the text out of, so I start with a new project in RMarkdown, and then I copy the text from my Word document and just paste it all in. And then effectively, it's a bit of a pain because you have to go in and sort of add those chunks back in, but in the end, I think it's worth it. It's sort of worth that initial pain, but it's really not too bad because fundamentally our Markdown or Markdown is just plain text, and so it makes things a lot easier. And then Pramit asks, how is our so our Markdown is not, our Markdown is different than LaTeX. So our Markdown uses a different kind of markup. So whereas LaTeX is much more heavy, I feel like, the Markdown in our Markdown is pretty simple. To use a header, you're just using these pound signs. You can use LaTeX. So for example, LaTeX symbols, so for formulas and things like that, you can use that in our Markdown, and you can knit to LaTeX output as well. I think the main difference is that with our Markdown, you can embed your code directly in it. So when people were first transitioning to these kinds of workflows, there was also a package called Sweave, which is where, like, the weaving is where we get the knitting as well from. And Sweave would render to a LaTeX output. I don't use LaTeX. I find that there's too much overhead and too much of a learning curve. I think that our Markdown just is sort of simpler. It's really simple to just get started. You don't need a lot of extra packages and programs to start using it, so you don't need to install MikTeX and worry about those packages. And because I can render directly to an HTML document, I think there's a lot more options available to me. Yeah, so Zavi, one of the things you can do, so Zavi's asking if it's possible to render into GitHub directly. So there's a couple issues. So one is that GitHub does not render HTML documents directly, but if you are using GitHub and you're using GitHub pages, what you will find, so this is my GitHub pages, oh, a second. So, so my website is actually hosted through GitHub pages. So if you go to goring.org, and on the back end of it, there are these resources, this resource page, and like all of my sort of things here, like this building a basic Jekyll website, these are actually rendered directly from RMarkdown. Oh wait, you can't see that. Just a second. Let me share again. Sorry, I was clicking to all sorts of stuff. So all of this, so this is my website, goring.org. And if you go there, this is built using Jekyll. You don't have to worry too much about that. But I actually have a GitHub Pages account, simongoring.github.io. Anyone can sort of add these to their, oh, whoops, I didn't go to the right place. Anyone can add these to their own account, their own GitHub account. This is just a repository like anything else. It's got some stuff in it, that's fine. One of the cool things is that once you add a GitHub Pages, you can actually get into any of your other repositories. So, for example, I could go to neatomadb.github.io. I can go to bulk baconizing, and then, what did I call that file? A second. But it lets you access those HTML files directly on the web if you've pushed them up. Oh, so it's just called bulk underscore baconizing. So, you should be able to access them. Neatoma. I don't know why I can't access that. Anyway, through GitHub Pages, in general, you should be able to access those as well, and pass that link. There is also a tool called HTML Preview that is a plugin for GitHub as well, and that lets you view those HTML documents directly through GitHub. But yeah, so yes, you should be able to. I just don't know why I can't right now. And having said that, all of these things are, like all of the pages on my resources page are generally, especially all the ones down here that use R, are actually RMarkdown documents. So there's, you know, a link about different things. So how to do spatial data on the web, stuff with regular expressions, graph databases, more Neatoma things. Here's this document about using continuous integration with our Markdown documents. That explains everything you need to do. But all of these were basically built with either Markdown or R Markdown. Any other questions?
So I don't know if we have some final questions for Simon, or if we set him free, or now. Chris is typing something, so.
Oh, okay. Thanks. And you know, one last thing to say is that, especially around our things, if people do have questions, let me know. Like, I'm always available by email. We do have a Slack channel for Neotoma, but I don't have the link handy, and I will post that as well. I'm just writing that in.
Okay, great. So I guess this concludes this
so.
this webinar.